interesting. So it's described as an order book for performing submarine swaps over Nostr. So there is a video describing it, and then it's talking about yield chasers. So that should be interesting for users. What problem does this solve? Well, you want plebs to be able to monetize their bitcoins. And so this is what this service is offering. Okay, so let's go back to what we are doing. So I'm Thomas, Electrum founder and developer. And so in Electrum, we have been providing submarine swaps for a few years now. And of course, the service that we run is centralized. We started to use the Bolts software on the server side, and then on the client side, we use Electrum. And then at some point we realize we don't need bolts because when you implement a client, you almost have implemented the server. It's the same logic. I mean, we can do swaps in both directions, of course. So then we used, currently we are using an Electrum node for our swap server. And it is exposed to the public via HTTP. But regarding the Lightning side, it is a private node. So it's not a public Lightning node. So earlier this year, we have decided that it's a really bad idea or a bad business model for us to provide the submarine swaps for different reasons. So we decided that we want to decentralize this. And yeah, so swaps are almost trustless. I mean, they are trustless, except that you can, of course, find a swap provider that is not following up on the request, and then you send an HTLC, and you have to wait a long time to get your HTLC back. But that's so that's what I mean by almost trustless. But nevertheless, we don't want to run this service in the company anymore, and we think we can do what Supertestnet said. Allow plebs to be yield chasers. I think it's a very good wording. So, yeah, I just showed your project when you were not here.
Thank you.
So, there are makers and takers. That means client and servers for submarine swaps. And what we do need is actually a big decentralized order book. And so I was interested by this project where instead of using a centralized service, we use Nostr in order to advertise the service. So why do we want to use Nostr? There are two things that are needed here. We need service discovery and we need client-server communication, RPCs. So service discovery, if you use Lightning, you could do this with service bits and announce the service in the Lightning gossip, okay? This is how you would expect to do, how LSP would be expected to announce their service. The thing is, our Lightning node is private, and so it's not possible to announce, I mean, we would need to announce the node. And if you want then to give this possibility to users to be able to be submarine swap providers without revealing their IP address, it would not be possible for them. It might be possible in the future with the future iteration of Lightning spec, but it's not possible at the moment. And so in Nostr, you can actually do, I mean, you can keep your identity private because the messaging, the service announcement goes with a Nostr message, and then the RPCs can be done via Nostr direct messages. In Lightning, you would want to use onion messages for that. Again, onion messages might work well, but not today, because today, if you look at the state of the Lightning network today, you still have a lot of nodes who do not forward onion messages. So both for the RPCs and for server discovery, at the moment, I think Nostr is a better alternative. And like I said a few minutes ago, we don't want to wait because we feel that this is urgent for us to no longer be a submarine swap provider. Okay. So here is the workflow. Bob is the server, Alice is the client. So Bob publishes a swap offer to his relays, his Nostr relays. Alice subscribes to this. So there is a Nostr kind for this event that is a submarine swap. And so Alice subscribes to swap offers, and she also mirrors the offers she gets to other relays, because you cannot expect Alice and Bob to have the same relays. So we rely on the users in order to mirror the information. And again, I'm new to Nostr. I'm not sure if this is the right way to mirror events, but this is how we have decided to do, and I'm open for feedback for that, because I'm new to Nostr, like everybody is, I suppose, because Nostr is new, but yeah. So Alice chooses the best offer, and then she engages with Bob through direct messages. So once she starts to send and receive direct messages, in the Nostr announcement, she sees the relays that are used by Bob. So at this point, Alice can send the message to one of the relays or many of the relays that are used by Bob. And then there is no mirroring needed anymore. So this is the format of swap offer. Yeah, maybe I should zoom. I don't know if you can see. This is really... I have to say, we started by using the bolts format for, I mean, the Electrum initially started as a bolts client. We used the bolts software for the server, and then progressively we have made some little changes, but you can still see that this is inspired from the bolts spec. So this is the Nostr event. It has a type, it has a version number, network, regtest here. There is the percentage fee that is taken by the server. So this fee is quite stable, but then you have also mining fees, and the mining fees, they are here, normal mining fee, reverse mining fee, claim mining fee. So these fees are changing frequently, so that means that the provider needs to update them frequently. Minimum and maximum amount are also things that might change quickly. There is a list of relays used by the server. So that's going to be used then for direct messaging. The pub key and the timestamp. So the pub key and the timestamp are from the Nostr message, actually. So the format of the Nostr message is everything, all of those fields except the last two, and the last two are, I mean, all of this is part of the content, and then there are also pub key and timestamp. So here is a request. Again, this is almost like in bolts. So Alice here is requesting a reverse swap. There is an amount, pre-image, hash, claim, pub key. And then relays, event ID, event pub key. This is the Nostr part. Response, again, you have also well, you have a reply to field. The reply to field is referring to the direct message, to the ID of the direct message that you're replying, and the rest is coming from bolts. Okay, so I'm going to make a little demo. This is how you configure the Electrum. Well, it's not all what you have to do, actually, but you need to have an Electrum wallet that has a Lightning channel and that is able to do Lightning transactions. So the first line is how you set config, you enable the plugin swap server so that you become a swap server. Then you have also to set up Nostr relays. Then you start a daemon, you load the wallet, and you should be, then you have an active server. So I'm not going to do this in daemon mode here. I'm going to use GUI mode. So this is the server that I'm starting here. And this is the client. So if you have already done Submarine Swaps with Electron, this is going to be familiar. You just go to your channels tab. You have this menu with this dialog for Submarine Swaps. Now the new thing is, if you have not chosen yet a swap server, then another pop-up is going to show up. It's accessible here. Choose a swap server, and here you have what I talked about. This is a list of announcements. They are sorted by age, and of course it's not the final version of the GUI. It's going to be much nicer. But here you have the public key, or the first bytes of it. You have the fee, percentage fee, and the age of the announcement. So I'm just choosing the most recent one because I just fired Bob less than a minute ago, and you see an announcement less than a minute ago. This is Bob. This is all using regtest, except for the Nostr part. The Bitcoin part is on regtest, and the Nostr part is actually using Nostr, because we don't have a regtest for Nostr. So at least you can see that the communication worked, because my client is aware of the most recent swap offer. So okay, I'm swapping 4 millibitcoins, and yeah, it works. 2 days ago, I did a demo that failed. Now it worked. Okay, so all this communication happened via Nostr, which means that the server does not have to expose a public IP address. And yeah, let me mine a block. I type new block, 2 blocks here. And now yeah, you need to mine a block in order to settle the swap. So the settlement transaction created a new notification. Okay, so I will finish just by a few words about the software that we developed for that. So there is this Python package called AIO Nostr. In Electrum, all the network stuff is done via async.io, and we found this async.io version. I mean, it's a package for Nostr using async.io. It's the best one and the worst one, because there is only one at the moment. So we have decided to use it, and we forked it because quickly we realized that there are some things that we want to change. So most importantly, it's using CoinCurve, and we don't want to use CoinCurve in Electrum. CoinCurve is a binding to libsecp. So we've never used CoinCurve in Electrum because it's drawing in too many dependencies. So instead of that, we use C-types. With C-types, you can directly, because that works because libsecp is written in C. If it was written in C++, you would need bindings. But with C, if it's pure C, then you can use C-types, and you can access C functions from Python directly without involving any dependency. So we have been doing that forever in Electrum using an Electrum module called ECC. And so for the sake of Nostr, we decided to ship Electrum ECC as a new package, separate, that is here. And we use this package in AIO Nostr. So we forked AIO Nostr so that it does not use CoinCurve anymore, but it uses Electrum ECC. Electrum ECC is a recent repo that we published in our GitHub project. And so what I want to emphasize here is this line, dependencies 0. So it's just, I mean, if you pip install this, it's going to compile libsecp for you, but it's not going to pull in any other dependency. Yeah. And then, so our fork of AIO Nostr is here. So the master branch is from the original author, and we have a branch called Electrum that is a bit ahead. Ideally, we don't know if the maintainer of AIO Nostr is still active or not, because I don't want to maintain a new fork of AIO Nostr, of course. So ideally, it would be good if this guy would accept pull requests from us. But we are 4 commits ahead now. Okay, so I think that's it. Yeah. Thank you for attention. Yes. Yeah, there is a question here. No? Oh, I thought it was you, actually.
So the incentives for somebody running a Lightning node to run such a service, it looks like it's like the current market going rate is like 0.5%.
Oh yeah. Well, yeah, that's what Okay, I mean, the incentive for users is to make money, of course. Like I said earlier, the current rate that we charge is 0.5%. Once we have published a version of Electrum that uses this decentralized system, we are going to increase our fee to 5%, so 10 times more. So that, I mean, so that you guys can create a service that is competitive with us. Yeah.
What is the timeline and what are the steps that need to happen in order for somebody running a Lightning node for this scenario to sort of play out?
Well, okay. Somebody running a Lightning node would need to, we would need to find an agreement on the protocol that I just showed you. This is why I came here also, is to have feedback from other implementations. Because now you really need to run an Electrum node in order to be a server. Okay, in this example, both Alice and Bob are running the GUI. I'm not sure. I mean, Nostr can allow users to really update their state quite quickly. So it would be possible to actually let users be a server while they are running the GUI, although I don't know if it's a good idea. I mean, currently you need to run a daemon. I just use the GUI for the sake of the demo, but currently you would really need to be a daemon. Yeah, so by the way, so this is the client. If I show you the history of the client, all the swaps that I did here are with a negative balance because this is the user who is paying the fee, and this is the server. So the server is earning fees, and the lines are written in black because then the server is charging fees. But if you were running this in the GUI, I don't know if it's a good idea because there is all kind of interaction with the user that could happen. So it's probably safer to start with a daemon. Yeah, we're going to raise our fees tenfold.
Sounds like you have an incentive for this not to work.
What do you mean? Not?
Then people will keep using your 5% service. I'm kidding.
No. Yeah, we don't want to be the most competitive provider. At some point, we're going to shut it down. Yeah. It's just a smooth transition. Okay, I mean, yeah, maybe we're going to raise our fees progressively, but we don't want to stop the service because users are using it, and then some user who rely on it would be annoyed. Yeah. But again, yeah, I mean, if another Lightning node is implementing a swap server, like for example C Lightning, and they are interested in this, we would really love to have the same protocol as them because then there is more offer.
Other than the fee, are there implications for the person running the Lightning node? Do they get more or less liquidity? Why would they, like, what would running something like this do to your liquidity, I guess? Yeah.
Other than the fee? Well,
you make money from the fee, but also you will change your liquidity. So why, like, could you use this as a tool for channel balance?
Well, that's what it's supposed to be used for. It's a tool for channel balancing. If you're running a server, eventually your channel will go out of balance because there is more demand for reverse swap than normal swaps. That means people tend to do more exchange where they send Lightning and they receive on-chain. I don't know why, but it means that if you're running a server, you will yourself from time to time to do a rebalancing of your own channels. Yeah.
Do you think it's possible that there's a world in like 5 years where most Lightning nodes on the network are like running swapping services where just fees go down to zero?
You cannot. Okay, the fee is not the only criterion of choice for a server because, like I said, our fee now is 0.5%, but it's still expensive because there are mining fees, and the mining fees you cannot remove them. So the way you can reduce mining fees is by pooling transactions and by Lightning Loop, they have a trick, which is instead of doing an extra transaction to claim the swap, they give you the private key. So it's a music 2 of 2, and they give you their private key. So at that moment, you can consider that this UTXO belongs to you. I don't think we want to do that in Electrum because our user expectation is that you can always recover your money from the seed words. I think some users would lose money if we introduce this kind of feature. But yeah, it's a safety versus price debate. Sorry, yeah, just to finish to answering your question, so the fee is a criterion for the choice of the swap server, but there is also what I would call reliability. Like I said at the beginning, there could be spammers who post an offer, but they don't follow up once you have sent them an HTLC. And there could be, I don't know, I mean, it can be malicious, but it can also be that something happened that is, someone who has an issue with that channel. You never know. So reliability is another criterion. That's why that's why in Electrum we are not going to automate the choice of the server to the lowest fee. It doesn't make sense. Once you have found a server that is reliable, you should stick with it, and you should change only if you are not happy with the fees. Yeah.
Yeah, really exciting. Thank you. I wonder, the Nostr identities, is this just some ephemeral throwaway npubs, or is it?
For the server, I think if you want to identify, I mean, if you find that the server is reliable, then you need to identify them by their public key.
Yeah.
For the end user, it could be totally ephemeral.
Okay, so for the servers, they would build up a reputable reputation over time.
Yeah.
And I wonder if this also helps with this free option problem that somebody can waste your time to basically use the Nostr web of trust to.
I'm not really familiar with the Nostr web of trust.
Yeah, just trust reputation.
Yeah.
Trustworthy npubs.
Yeah. I thought about implementing something very, very basic in the client, which means how many successful swaps did you have already in the past with that given pub key. But web of trust is another dimension.
How do you prove the successful swaps?
Your own history, you know it because it happened.
Okay, your own experience.
Yeah. I'm not talking about web of trust.
Yeah, my last thought was, why not use Nostr for incremental backup of this loop trick that you mentioned, that you get a music partial signature?
Excuse me, to do a software update?
No, incremental backup. So store the data in the Nostr.
The trick that loop uses.
Yeah.
But then you lose you said then you can no longer recover from yours.
Yeah, the reason why we, I mean, my philosophy as the user expectation in Electrum is that you can recover your channels from seed. If it's if you're just accepting a UTXO because there is a private key, are you saying you could back it up in Nostr?
So the Electrum seed could the npub Nostr identity could be derived from the Electrum seed, and then all the data could be stored as to self-encrypted. Nostr messages.
Yeah, you can do that, but there is no guarantee of data permanence in Nostr.
Sure, the relays might lose it.
Yeah,
true.
I mean, you could do all kind of crazy shit. Huh?
Yeah, keep the Nostr weird.
Just a general submarine swap question. Is it possible to prove past swaps that you've done to increase your reputation by like showing, I don't know, HTLC signed by your counterparty plus on-chain transactions or something, or are you then...
To have a public proof that you have...
That you did past, yeah.
Yeah, maybe, yeah.
I mean, you could fake them, but there's transaction fees that have to be paid, so maybe...
I think in the latest thing, it just looks like that proof, but
But we could just fake it, just make a lot of fake swaps.
I don't know.
No,
Yeah.
but people in my web of trust, if other people that I trust who trust them,
You
they
could
had good
you could
experience.
first open timestamp the request you get from the user. I mean, this is a I don't know. This is getting no.
But don't you know which Lightning server is providing this based on the invoice that you're paying? Don't you know? So wouldn't the reputation come from the Lightning server that is offering the service in the first place? So if you have like a good standing Lightning node,
maybe, but I think then you would need to include the script that you are paying to in the Lightning invoice, that the part that is protected by the signature, because currently it's a different field. Yeah, that. Yeah, yeah, indeed. Oh, yeah, of course. Yeah, the same pre-image. Yeah, yeah, you don't need that. Okay.
So like, yeah, you could fake it, but if someone is making thousands of on-chain, it could be fake, but if someone's making thousands of on-chain transactions just to fake his reputation, for then someone to just try once and then lose the transaction, I mean, that sounds kind of futile, but if someone has really thousands of transactions that look like submarine swaps, it might be a good indication that the server actually does submarine
Yeah.
swaps.
Well, I leave that as an exercise for the reader.
Perfect.
But I think it might be possible indeed to build a web of trust based on that.
It's not really a web of trust, it's more like a
It's more proof.
reputation
Yeah, it's a
scheme.
harder proof than a web of trust, indeed. Yeah. I don't know if users also would be comfortable with everybody knowing that this particular transaction is a swap. Yeah.
Everything is better than a blank list that just says published a minute ago, you know?
Yeah.
Like if you have zero to go off from your own history.
Okay. Another question? No? No? Okay. All right, then thank you.
Well, thank you.